Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, number 8 of Neet Physics paper 2017. Students, let us solve question number 8. The question says, figure shows a circuit that contains 3 identical resistors with resistance R equals to 9 ohm. Basically the diagram is, what is given in the question paper is like this. This is a ideal battery of EMF equals to 18 volt, which is here, and the resistances are one resistance and one coil, then one resistance here, then one resistance here, and one capacitor here, and one coil here, and is connected to this. So this is the diagram where I will call this is R1, this is R2, and this is R3. 3 resistors. Each of resistance, so R1 equals to R2 equals to R3 equals to 9 ohm. Each. 2 identical inductors with inductance 2 millihenry. This is inductance L1, this is L2. L1 equals to L2 equals to 2 millihenry each. And an ideal battery of EMF 18 volt. So this is an ideal battery, so no internal resistance. Ideal battery means there is no internal resistance. The current I flowing through the battery is given by, so the current will flow like this, and we have to find the current flowing through this battery just after the switch is closed. Now, this is a very basic question. This involves the resistance, inductor, and the capacitor C. See here. So when at the time t equals to 0, when we switch the circuit, switch goes, then the capacitor behaves like short circuit, and the inductor behaves like open circuit. Okay, they behave like open circuit. So at time t equals to 0, because it says that the current flowing through the battery just after the switch is closed, just after the switch is closed is that means time t equals to 0. So this means that this will be open circuit, and this will be open circuit as if it is disconnected, and this will become short circuit. This is becoming short circuit because this is open, so there will be no current flowing through this because this is open circuit now, and no current will flow through this, but the current will flow through this like this. So the current will flow only through this, and from here it goes through this, and like this returns to its original position. So this is the path of this way also it will go this way. Current will not flow through this branch or through the inductor, this inductor L2 or this inductor L1, but it will definitely move through the capacitor. If properly we solve this, then we know that the circuit is equivalent to, I'll draw the circuit again. This is the circuit now. Resistance is there, but there is a gap because inductor is open. The resistance here is R2 and it is connected. Here it is R3 and inductor is there, open circuit. But there is a capacitor which is short circuit. It is like this. This is a capacitor over here. This is R3. This is R1. Inductor behaves like open circuit, no use, and the capacitor is a short circuit, just like plain wire. it is like a capacitor behaves like a plain wire. So, and this is your EMF, which is 18, and the current will move like that. So this is like two resistors in parallel with the battery. So EMF of this battery divided by the total resistance, obviously it is the net resistance, that is equal to the current flow through this. When two resistors of equal value are in parallel, we know that the net resistance will be product by sum. So it is R2 R3 divided by sum, which is R2 plus R3, which is 9 into 9 divided by 9 plus 9, which is 9 into 9 divided by 2 into 9. So it is 9 by 2, which is 4.5. This is 18, EMF is 18 divided by 9 over 2, so it is 4 ampere. This is the actual answer to this question. But if you see the option, there is no 4 amperes. This means this circuit is not proper. Firstly, the diagram is not proper. So to get the answer for this question, what they have actually done is this they have not considered. This is open and they did not consider this one. They did not consider this one and also this one. Only they consider this current through this one only. So what they've done is, this is the EMF. There is one resistor here which is open circuit, resistance and open circuit. One resistance here, R2, and the other one is also R3 and that is also open circuit. They have done like that. Probably capacitor is ignored, so therefore it's only R2 here, but the current is flowing like this. The current is flowing from only through this part. This is the only path through which the current is flowing. They have assumed like that, but which is not right. Otherwise you have to draw the actual diagram. If it is so, then E equals to 18 here and R2 equals to 9 over there. So I will be E over R, that is your R2, this is 18 by 9, which is 2 ampere. So if you go by that, then 2 ampere is the answer and it is the option number 3. So to get this to get the marks, you will obviously write 2 amperes, but the diagram is not proper. Okay, the answer to this question is 2 ampere. Okay, thank you.